Hello, and welcome to our webinar today, ArcGIS for Developers, a National Security Focus. I'm your moderator. My name is Scott Ward, and I'd like to thank you for joining us today. First, I'd like to cover some administrative details. You can ask questions through your chat window, and we'll answer those at the end. The recording for this webinar will be posted soon after if you'd like to review it in the future. Now I'd like to introduce you to my colleagues. Today, we'll have Kerry Robinson, Principal Product Engineer, and Rex Hansen, Principal Product Manager, presenting on the recent changes to our various developer environments in the national security setting. With that, we'll get started, and I'll hand this off to Kerry.
Thank you so much for joining us today. It's a pleasure to be here to present to all of you. Today, Rex and I are going to follow on from the first webinar from a few weeks ago, discussing ArcGIS for developers with a national security focus. In particular, we'll talk about how we can enable digital transformation for operational environments. In the national security community, it's imperative to have an understanding of the operational environment in order to be successful at our work and in our missions. If we don't build systems leveraging a modern open architecture, then we spend a lot of time and money building systems where we have to engineer the integration in, and we end up with duplicate code and wasted effort. These systems need to enable people to work together and require integrations between systems across functions, domains, and sharing information from strategic to tactical levels. We need to build systems that leverage geography as a science, because geography is what connects everything. And GIS is a technology, including software, databases, and APIs, so that we can create understanding and make better informed decisions. Today, I'm going to review some of the key concepts that we shared in the ArcGIS for Developers webinar from a few weeks ago, including how WebGIS provides a modern GIS architecture, how a geospatial infrastructure powered by WebGIS is the foundation for transformation within organizations, how ArcGIS is an open system to provide a geospatial infrastructure, and how ArcGIS provides powerful APIs and SDKs to enable you to extend and leverage this geospatial infrastructure. I'll be putting all of these in a national security context, and I'll share 3 use cases with demonstrations and then a few success stories from customers who are already adopting this pattern. And just as a note, while this presentation is geared towards developers and project managers, we're not going to do a deep dive. We're not going to be showing any code. We're going to be covering a lot of these high-level concepts. But we will be sharing several resources with you during the presentation so that you can take what you learned today and then dig a little bit deeper. So GIS is at the heart of what we're talking about today. And I'm sure some of you are already familiar with GIS and have been working with it for years. And some of you might be new to it. We believe that an improved common understanding of the operational environment is achieved through a system, a GIS system, that allows us to organize, understand, and exploit the world's knowledge. It aggregates and integrates all data from various sensors and sources. It can be modeled on a framework, such as the PMISI A-Scope framework, while also streaming in more dynamic or live data, such as weather, sensor observations, Blue Force tracks. It also allows you to create a digital twin, or twins, of the operating environment as the core of this system. So it's geography-based, it can be true 3D, and time-enabled. National security missions require GIS. It's a key aspect of all the work we do, whether we are concerned about monitoring and maintaining our facilities, the health of our workers, logistics, training, modeling and simulation, intelligence, operations, and of course, it's essential technology used by our mapping organizations. But all of these leverage GIS. GIS has been around for decades, for 50 years or so now. But WebGIS is the modern architecture to help us do our work better. This is because it leverages web services, and it's designed from the ground up to enable sharing and collaboration and to work in a distributed and interconnected way. WebGIS helps drive digital transformation. This is because it gives us a framework to move from or integrate with legacy stovepipe applications and systems to the next generation of systems built for integrated operations, which is at the heart of enabling organizations to work more efficiently and effectively. WebGIS enables a common understanding. It delivers capability through a single pane of glass. This single pane of glass can still be role-based and tailored to user needs. It delivers near real-time data and analysis for the analyst and for the consumer. It delivers actionable intelligence with rich content. And it delivers capability to users based on their compute environment, whether they're in their home station in a static headquarters or whether they're out at the tactical edge. WebGIS enables us to build a geospatial infrastructure to support all of these things. So how do you build this geospatial infrastructure? ArcGIS is an integrated system that brings many components together and has been engineered to work as a single system, supporting many kinds of applications and people. ArcGIS Enterprise is our server software that enables a web service architecture, a professional desktop application called ArcGIS Pro, and many apps and APIs to allow all of this capability to be embedded into other systems. As a technology, it's what's enabling and fueling this geospatial infrastructure pattern. ESRI recognizes that warfighters and responders often operate in disconnected, intermittent, and low bandwidth networks. So it's essential to support those environments and those workers at the edge. We extend the geospatial infrastructure to the edge, leveraging distributed edge computing and edge devices. It means having a complete GIS system in a remote or austere environment, on a vehicle, or in the palm of your hand. ArcGIS is an open system designed to integrate into large, heterogeneous, and constantly evolving systems. ESRI partners and customers integrate ArcGIS into the systems used in national security organizations around the world. It works with industry-based open standards. It provides open data. It leverages open source and includes hundreds of open source projects. It's configurable and extendable using low or no code applications. And it provides several APIs and SDKs to extend GIS into your own workflows. It's also engineered to support the secure networks and environments that you require, including those secured using integrated Windows authentication, smart cards, and PKI. We do our best to replicate some of these secure environment configurations in-house so that we can discover any potential issues and make sure that we fix them before we release the software. So ensuring ArcGIS works within your secure environment is a priority for us. ArcGIS integrates all types of data. Of course, geospatial data, such as imagery and maps, but also tabular data, unstructured data, real-time data, LiDAR, building models, etc. These can all be mashed up and integrated dynamically through an abstraction layer that we call a web map. This is the primary interaction or access point in a WebGIS architecture. And this is the, so this is the foundation for delivering powerful capabilities across your organizations. And it's made available through a variety of different apps, mobile apps, web apps, and desktop apps, each serving a different function to put GIS into the hands of users, and each being able to read and leverage the web map. All of these apps are based on APIs. So now let's take a developer view of ArcGIS, so you can understand how you can tap into this geospatial infrastructure. On the left, we have APIs that configure, customize, and automate ArcGIS. As we move to the right, we have the runtime SDKs, which provide APIs for native devices, so Windows, Linux, iOS, and Android. It also now includes plugins to game engines for integration with extended reality systems. We have a JavaScript API for building powerful, fast, and responsive web applications. And we provide location and geospatial services that can power open APIs such as OpenLayers and Leaflet. You can see there's several ways to configure and extend ArcGIS to power the systems that you're building. As developers, you can pick the platform that's most appropriate for the system you're building, and then also choose the API that you want to use, and you have the assurance that all of the ArcGIS capabilities are available to you. Ewan spoke about each of these APIs in a lot more detail in the previous presentation, so I'm not going to do a deep dive in each one of them. So What we are going to do today is to go over some use cases that are relevant to national security. We'll demonstrate a few capabilities and products and examples of applications that are all powered by ArcGIS and these APIs. We'll start off with talking about intelligence preparation for operations. Rex will talk about integrating game engines for decision support, and then we'll talk about how we can support operations and situational awareness. Everything we show is an example of an application built by configuring, extending, or customizing ArcGIS, and we'll be sure to point that out as we go along. In this diagram, while we're using a military force as an example, it's a good illustration of how geospatial infrastructure enables all components of a national security organization, whether it's military or civilian, land, air, or sea. The geospatial infrastructure that hosts content and services across the enterprise also provides access to tools and workflows and links data sources and sensors through to the end users. The geospatial infrastructure provides access for specialist users to undertake tasks such as the management and provision of foundation environmental data services, so the operational environment. The ability for intelligence staff to analyze and exploit intelligence, which can then be shared for the operational planners as they develop and formulate plans. The result is that operations staff have the content and the tools to enable shared situational awareness, which supports the decision-making process. So first we'll focus on intelligence preparation for operations, which is mostly the left-hand side of this diagram. It's really about the creation and analysis of the operational environment, building that digital twin. Intelligence preparation for operations, otherwise known as intelligence preparation for the operational environment, or intelligence preparation of the battlefield, and there's a few other terms for this, but it's an essential part of the decision-making process. It integrates information on the enemy, weather, and terrain, and provides the basis for situation development, target value analysis, collection and reconnaissance and surveillance planning, and battlefield decision-making. ArcGIS is a system for IPO, and I'm going to talk about a few key aspects of this. I'll start off talking about a product we released called ArcGIS Pro Intelligence, and I want to talk about this for a few different reasons. First of all, ArcGIS Pro Intelligence is a fully supported product for the intelligence professional. It's a very powerful product with a streamlined interface, and it includes tools to support intelligence preparation for operations, such as data integration, visualization, several key ways to analyze information, and then the ability to create intelligence products. The other interesting thing about this product is that it's built using the ArcGIS Pro SDK. So it's also a really great example of how you can extend and leverage the powerful capabilities of ArcGIS Pro, but provide it using a very focused and streamlined interface for your audience. I'll show a demonstration of this in a minute. I also wanted to spend a few minutes talking about support for military symbology and working with standards-based symbols. In ArcGIS, we support the US and NATO symbol standards, so MIL Standard 2525 and AP6 specifications. Using dictionary symbology, it works across all apps in the ArcGIS system. We've built it in a way that you can ensure that everyone can build maps and visualize data using the same authoritative set of standard symbols. These symbol dictionaries can be deployed locally on a device or shared on the network. It's called a symbol dictionary because you can look up the correct symbol in the dictionary based on different properties of the data. This includes a symbol ID code. ESRI provides the symbol dictionaries for the US and NATO symbol specifications, but these are also customizable. So you can add new symbols and modify existing ones. For example, if you want to extend what the standard provides to be more applicable to the system that you're building. You can also create new symbol dictionaries from scratch, and we have several customers who are doing this. One example is in Germany. They're building a symbol dictionary for their public safety symbol standard. Currently, there is no digital implementation of that specification, so building this as a symbol dictionary enables any German law enforcement agency to use the same set of symbols in all of their apps. we're seeing this pattern actually happen a lot around the world, in particular in the public safety domain, as there aren't these existing kind of common symbol standards that are implemented digitally. So now I'll show a video of a demonstration of ArcGIS Pro Intel. Okay, so this is ArcGIS Pro Intelligence. If I open up my project here, we can see that I have a set of tabs up at the top that I can use to support different workflows. So I can integrate different data and visualize my data. I can perform several different analysis functions. I can import and analyze and work with imagery. I can edit, create plans and sketches, and then I can disseminate that information as well. So I'm going to jump in real quickly and do a quick overview of some of the different things you can do with Pro Intel. I'm here in Monterey, California. That's my area of interest. And if we go to the Data tab, we can see that there's many different ways that we can import different data. In this case, I already have an imagery base map that I'm working with. I have some terrain data. I can bring in some ENC S57 data, so we can get that rich content. I'm able to filter out just the land data so that I can kind of blend it in with the imagery that I have here. I also can bring in real-time feeds. So we can see we have some friendly land tracks, some air tracks. We have a drone that's flying around over here. And then we have some sensors that are observing things in the field and reporting them as well. So we've brought that in as a feed. So we have some real-time data that's brought in. We're using military symbology. In this case, we're using the MIL standard 2525 Bravo to symbolize the data. Now, we also have the ability to perform analysis. And you can see on the analysis tab here up at the top, there's many different types of analysis we can perform. There's time analysis, suitability analysis, visibility analysis, movement analysis tools, temporal, predictive, descriptive, lots of different tools in the toolbox here that can be used. So I will just show the results of some of the analysis that I've already performed. Looked at the terrain and our objectives and have determined some named areas of interest here. I've looked at the number of incidents that have occurred along my lines of communications, and so my road network, and I can see them here depicted in the darker red is where there's been a higher occurrence of incidents. I've done some cover and concealment analysis. And then I've determined where there's some helicopter landing zones as well. And finally, if you remember from the presentation a few weeks ago, Ewan showed a video of using artificial intelligence to analyze imagery and determine where potential surface-to-air missile sites are. And we've determined that there are a few here in this location. So now what we want to do is sketch a plan, determine our possible courses of action. So I'll actually turn back on my cover and concealment here. We can use that to help us determine the plan. And I can use our military symbology tools to sketch some tactical graphics. I'm going to do this fairly quickly. Okay, so maybe some other hostile activity has been discovered. We've seen some tanks in this area. A howitzer maybe in this area. We want to make sure that we isolate. So as we draw this isolate symbol here, we see we can have this responsive view, kind of a WYSIWYG view of the symbol, so we get a better idea of exactly where we're positioning it. So protect. protection line around the airport. Maybe support by fire. This is another one where you can see the symbol draw as we add these anchor points here according to the symbol specification. Maybe some fade lines. For the axis of advance, according to the specification, you draw the arrow tip first, and then you lastly specify the width. So it gives us a lot more control over what we're drawing. I'll just draw another one here. So you get the idea. This isn't necessarily a complete plan or very accurate perhaps, but you can see how we can use these military symbology drawing tools within ArcGIS Pro and ArcGIS Pro Intelligence to create courses of action and tactical graphics. So now that we have our map, we've done our analysis. At this point, we want to be able to share and disseminate this information. And so if I go to the Disseminate tab here, there's lots of different ways we could do this. We could publish as a map service or a feature service or an OGC, WFS or WMS. We can publish the whole map together as a web map, and this lets it be used within a web application. We can package it together in a mobile map package, which allows it to be used in mobile devices. So you could, it packages all the data together so it can be used completely offline. We can create an OGC geo package. We can also export the map. We can capture essentially a screenshot and include that in a PowerPoint. There's lots of different ways here to disseminate the information. And so that's my really quick demo of ArcGIS Pro Intelligence and how you can use the Pro SDK to customize the user experience of ArcGIS Pro for certain workflows. Okay, yeah, so the plan that I sketched there, I'm sure is not very accurate. Some of you might pick up on that, but hopefully you got the idea in terms of the tools that you can leverage. And that web map that I created, I'll be showing in a demonstration later on. So next, Rex will talk about how our Maps SDK can be used to integrate the operating environment into game engines for decision support. So I'll hand over to Rex now.
Okay, great. Thanks, Carrie, for the rundown and the introduction there. Before I dig in to talk about game engine integration and being used to support decision making, I want to provide a brief overview and maybe some background on really how we got here and why what we're doing, really bringing GIS to game engines, why that's important. So one thing we've noticed over the past few years is that a number of industries, enterprises, businesses are pursuing their next generation of 3D GIS solutions. Now, as these solutions apply to the real world, they need to leverage existing authoritative geospatial systems and also take advantage of new technologies to gather, store, and distribute geospatial information. Of course, ESRI, we're the global leader in this space, and we provide the system to manage, maintain, utilize geospatial data and analytics, and we are, and we should be at the forefront of defining new standards and technology to deliver access to high-fidelity geospatial information. Now, these new 3D GIS solutions include client applications that target specific workflows that require photorealistic experiences powered by real-world data. They need to take advantage of high-end graphics, capabilities on modern devices, utilize hardware designed specifically to support extended reality experiences like headsets to power AR, VR workflows. The applications need to be highly interactive, responsive, and intuitive. They need to be designed to be visually compelling, immersive, and as realistic as possible to increase engagement, improve understanding, and optimize the environment for making decisions. Operationally, they need to support modeling and evaluation of phenomena in the real world, simulating natural and human-oriented activities and the interaction between them in the past, present, and the future. In addition, they need to render dynamic data quickly, dynamic geospatial content quickly, and make it accessible in the office and in the field for rapid analysis and decision-making process. Now, a number of industries have already embarked on this effort, and they're pursuing targeted solutions founded on game technology. Now, this is more than just gamification of GIS solutions, which is basically the use of game-style interaction patterns to drive and empower users of software. It's the use of game engines to build the next generation of 3D GIS clients and experiences, really applications, on new devices with new expectations. These industries and solutions include AEC for urban planning, maybe commissioning new construction, evaluating work sites in the field, and most importantly, visualizing a digital twin for use in real-time analysis or simulation. In defense and public safety for collaborative battle situation planning, real-time monitoring, situational awareness, threat detection, really immersive yet cost-effective training capabilities. And natural resources to manage oil and gas pipelines and facilities, plan mining efforts and monitor infrastructure. In utilities to model resource flows, evaluate impact, and visualize and manage assets in the field. In transportation, to capture and manage geospatial assets, plan for new infrastructure, and model vehicle movement. And lastly, in education, to really help drive a greater understanding of the world around us, by delivering engaging experiences to do things like explore a thunderstorm or visualize the potential impacts of climate change. So there's other client technology out there in the web and native space to build out 3D applications, immersive interactive experiences. Why game engines? Well, as game engines have targeted gaming experiences, it was essential that they deliver high performance, premium rendering of content with fast and fluid interactions that meet and compete in the gaming space. The highly competitive nature of the gaming industry really helped push game technology and associated content and hardware to the limits of their capabilities. As such, years of development have been invested by successful game engine vendors to build out premium, high-definition rendering pipelines to deliver simulated world experiences optimized for multiple platforms and form factors. Of course, to build a more immersive and compelling experience, game engines also invested heavily in systems and APIs to simulate real-time interaction and movement of real life. The introduction of high-fidelity assets, physics engines, animation properties, atmospheric, water, and other special effects has enabled some game engines to deliver beautiful, photorealistic, cutting-edge visuals that appear and operate nearly identical to the real world. Game engines also provide support for targeting a wide variety of desktop and mobile platforms and dedicated specialized hardware. Part of the next generation of 3D GIS solutions include business use of headsets dedicated to extended reality workflows like HoloLens or Oculus Quest. Game engines are built to support the responsiveness, the frame rates, and the fidelity needed to power those experiences. And last but certainly not least, successful game engine vendors have existing developer programs and communities. They've got help doc, forums, tutorials, and talented individuals and organizations that know the technology and are available to do the work. So with that in mind, we are delivering the ArcGIS Maps SDK as a developer product that integrates with the two market-leading game engines, Unity and Epic's Unreal Engine. The ArcGIS Maps SDK for Unity and the ArcGIS Maps SDK for Unreal Engine are currently available in a beta program where they're distributed as plugins. Now, these products provide the foundation for bringing GIS to game engines. They provide a geospatial context for the use of real-world ArcGIS data through services and local packages, online or offline. Game engines provide the high-fidelity visualization of structures, terrain, and features from ArcGIS data sources. Game engines also deliver enhanced special effects, analysis tools, and the ability to target a wide variety of devices, as I mentioned before, notably those dedicated to extended reality or AR/VR experiences. So let's show a few examples, a few use cases, actually, of how integration of ArcGIS with game engines is having an impact on decision making. So first, ESRI and our partner Presage have been collaborating on a showcase of route analysis through simulation. This is the beginning of an opportunity to really solve complex problems in digital twin generation for military training, scenario analysis, and asset tracking. ESRI's technology provides the foundation for mapping, basically the storage and distribution of accurate geospatial data and a real-world canvas. Presage's simulation and training technology provides rapid analysis solutions through their Stage software, a widely adopted computer-generated forces solution. The initial demo focuses on evaluating emergency or tactical response scenarios where a hero vehicle must traverse a road network from a starting point to a destination. An up-to-date road network with accurate transportation systems such as signals and signs, and multiple simulation variables such as frequency, density, and movement of vehicles may impact the movement of the hero vehicle to the destination. Now, Unreal Engine provides the front-end framework to visualize the geospatial context with real-world data powered by the ArcGIS Maps SDK. While operational information derived from Presage's stage simulation software is delivered and overlaid in real-world coordinate space to provide visual results for decision-making purposes to discover trends and possibly alter variables. So let me share the video here. Okay, so in this demo, we're showing this prototype that I just described in action. We're using Unreal Engine. The Maps SDK provides the geospatial canvas to use real-world data and access to a scene layer of type integrated mesh that represents a section of San Francisco that was provided by Vexel, collected at 7.5 centimeter resolution. The density and placement of traffic or vehicles that represent traffic is handled by Stage, which we saw there. This information is pushed to Unreal Engine, which shows these vehicles symbolized using models that represent vehicles for more realism moving on a road network. And that road network is used and available to Stage. The hero vehicle location is marked with a pin or a lollipop to see where it is on the landscape. Variables that affect the progress of the hero vehicle can be difficult to assess with the naked eye, such as traffic density or speed. So we can use these interactive visualization capabilities of Unreal Engine and a dynamically generated heat map with a 10 by 10 grid on the area of interest to better communicate these variables as they change during the simulation. Now we can notice the hero vehicle starting to move. We can see some of the vehicles starting to move on the canvas. We have a certain element of realism here that we can utilize within the game engine itself. As it transitions through an intersection, we note that other vehicles respond to variables that we've set, such as the honoring of different signals or making sure that we don't have collisions on this space as well. What we will notice around the city is a realistic view within this area of interest. There we go. So because the interaction of a variety of different variables can be a bit difficult to notice at the level of at the resolution that we're looking at a city level. In this case, we're going to be using a dynamically generated heat map. This is a 10 by 10 grid on the area of interest to better communicate these variables as they change during simulation. So we can alter different values here, such as traffic density or speed, and we can see how that impacts the ability for or the transitory ability for different sections within the city. Now, really, this is really just a prototype. This is just a start of this effort. There's more to come here for sure. It is important to note that there are many simulation engines available, and while this proof of concept is built on geospatial capabilities of ArcGIS and visualization enabled through the Maps SDK and Unreal Engine, other simulation engines can be utilized in a very similar manner. Okay, great. All right, the next slide, there we go. Okay, cool. So in this example of a business application, we'll hear directly from one of our customers, Simon Bowles, who's the general manager at EIC Activities, part of Cimit Group, Australia's largest construction, mining and services provider, about how the ArcGIS Maps SDK for Unity is helping them build their projects in the virtual world via a new initiative they call Virtual Builder.
Hi, I'm Simon Bowles from EIC Activities. The best way to describe Virtual Builder is a flight simulator for construction. A dynamic, interactive, 5D digital environment where permanent and temporary elements such as materials, plant and resources can be manipulated in time and space to create a virtual construction site. Construction is a highly complicated environment, often with hundreds or even thousands of people and machines working alongside each other. Unity's gaming engine and our event-sourced architecture provides the ideal collaboration and integration platform to make sense of this complex environment. By using physics and colliders to perform spatial temporal clash detection in real time, we can see what's happening, as well as what's going to happen as work progresses and plans evolve. This instantaneous feedback is incredibly valuable to us. ArcGIS Maps SDK provides the ideal stage for this virtual construction to take place. Powered by the ArcGIS system, it represents the starting point, the initial geospatial environment that gets transformed into the finished product. As this example shows, the key to Virtual Builder is that the rules work the same as in the real world. Things can't just appear of their own accord. They take time, money, and resources to build. Using data that is integrated across the design and construction workflow gives us some powerful capabilities, such as recursive computation and parametric modeling. Virtual Builder's ability to look forward in time enables our delivery teams to provide accurate and timely constructability input into the design process. Having good visibility of the future impacts of decisions we need to make now means better solutions for us as contractors, which ultimately means better outcomes for our clients.
Great. So a great example of a business application from EIC Activities, and some ways that they're using that for better visualization for decision-making and construction opportunities there as well. So let's take a look at the last demo. Great. So in this final demo from our user conference plenary last year, 2021, our ArcGIS Maps SDK development lead, Adrian Mario, is going to take us through a tour of how ArcGIS data can be integrated with a game engine using the Maps SDK and really take advantage of other ESRI technologies such as City Engine and procedural rendering and leverage the power of game engines for photorealistic rendering, special effects, animation, and simulation in extended reality experiences.
Now, we're going to travel to the city of Bendigo in Australia and appreciate the incredible data created by our partner, Areometrics. The details look amazing, even at the street level. Look at this pillar in front of the art theater, next to the historic fire station. The Maps SDKs make it simple to add these types of layers to the scene, and the development environment removes the complexity of dealing with large data sets and different levels of details. We are now looking at the courthouse right next to the visitor center. We'll pass quickly all the shops on Williamson streets, and the one on ArcGIS Mall. We're now on the street that feels a little bit closed in. With game engines, you can import content from other applications. Here, we've created an urban planning scenario using ArcGIS City Engine, procedural building rules, and David Wesselman's complete street rules. You can see how this design fits with the rest of the city. It feels now much more open and really enjoyable to just walk around. You could use this immersive experience to present to the city what the future of that city block might look like. With City Engine SDK, you can procedurally generate data directly inside the game engines. You can start with an empty parcel and just add a City Engine rules to it. Then game engines will generate the building procedurally with the streets. You can also change the rules parameters, like the setbacks here, or the numbers of floor, directly, and see it happening directly on the game engine. Now, let's add some vegetation and street light to our experience, coming from the game engine's assets libraries. Look at those beautiful trees swinging in the wind. We now have a really beautiful looking digital twin of what that city block might look like in the future. Next, let's talk about the biggest advantages of using game engines. And those are visual effects and animations. This is how you can add another dimension to your experience. Look at this beautiful sunset, for example. You can see the light interacting with the tree leaf. Now the street light turns on at dusk, and you can look at the stars. We even just saw the moon. We can even change this sunny day into a thunderstorm. Particle systems are a key component of visual effects. Game engines provide easy-to-use tools to be able to create and control those particle systems. That's how artists can create effects like atmosphere, clouds, and rain. Not safe to have an umbrella anyway. Next, you can add and animate real-life characters into your scene. Having live character to your scene will really help everyone understand how the space will be used. Look at those people enjoying the outdoor cafe on a sunny afternoon. To bring more realism to our streets, what we need, of course, is cars. Cars' positions can be animated following a script or using real-world sensors. Oh, sorry, I need to move out of the way. Sorry. We've created this amazing immersive experience once, but we can deploy it to multiple devices. This one, of course, but also via headset, tablets, or phone. The simplicity of deployment is one of the reasons why virtual reality experiences are mostly built using game engines today. Let's talk about augmented reality now. I have now on my phone an application that allows me to look beneath the streets at the underground utilities. This is what we call real-life AR. Uh-oh. I think we're having a problem. Our newly designed cafe is on fire. Once again, we're using particle system to create this real-looking fire. And lastly, we can transition to this tabletop experience, giving us a top view of the city of Bendigo. Tabletop applications works as augmented reality on devices like phones or tablets, virtual reality on VR headsets, or mixed reality on devices like HoloLens. And they can all be powered with one single game engine project. They're good for situational awareness, advanced planning, and collaboration. Here, we're showing the position of the emergency responders on their way to the fire, represented by those red cones. We can also see the effect of the smoke on the city, depending on the wind direction and speed. And that was a quick tour of some of the things you can do when you bring GIS to the game engines using the ArcGIS Maps SDKs.
Great. So an Academy Award-winning performance from our development lead for the Maps SDK by Adrian. And with that, I'm going to finish the game engine section, and I'm going to hand it back to Carrie.
All right, thank you, Rex. I love seeing those examples. I never get sick of seeing them, and I'm really looking forward to the Maps SDK release. So thanks for sharing that. So finally, I'm going to talk a little bit about how GIS can be used to support operations and situational awareness. This includes supporting operations staff in the static or deployed headquarters, as well as those who are in vehicle or on foot, who need a common operational picture and shared situational awareness over reliable or unreliable network comms. Some of the critical capabilities needed for situational awareness include integration of feeds in real time, understanding the locations of your friends and enemies, dynamic visual analysis like viewshed and line of sight, analysis of data streams in real time to understand anomalies and patterns, collaboration tools, and the ability to work completely disconnected, but still leveraging that single pane of glass that I spoke about earlier. So clearly the ability to visualize and analyze information in real time is absolutely critical. ArcGIS has solutions to do this, and in particular, GeoEvent Server, which is an extension to ArcGIS Enterprise, and ArcGIS Velocity, which adds these functions to our ArcGIS Online SaaS environment. They support ingesting real-time data and visualizing it and analyzing it so you can be alerted when certain conditions on your data are met. I also want to highlight another product we have called ArcGIS Dashboards. This is a no-code option for providing dynamic, real-time visual reporting about any subject. Dashboards have become almost an essential element of GIS in so many organizations, and they've been embraced by our users to be able to provide at-a-glance information. These were particularly used during COVID, and you might have seen the COVID dashboard provided by the Johns Hopkins University. Not only is it a great and easy tool to configure by any user, Dashboards is written using our API for JavaScript. So it also gives you as a developer an example of the types of real-time dashboard-like applications that you can build according to your needs. So next I'll show a really quite simple demonstration of the JavaScript API. The first one being Dashboards, which is this no-code option for building an app, and also just a really simple custom application that's showing feeds from GeoEvent Server displayed using military symbology in 3D. So first I'm going to show an example of using ArcGIS Dashboards to view the current situation in a browser. ArcGIS Dashboards is written using our JavaScript API. So it's an example of how you can use our JavaScript API for this kind of application. It's a configurable web application. And so I've configured a really simple version of a dashboard here where I've brought in the map that I created earlier in ArcGIS Pro Intelligence. We could see the real-time feeds of our friendly land tracks, our air track, our drone that's flying around, and some of these observations that are being captured by sensors out in the field. And we have our named areas of interest here. And we can see I've set up actually some geofencing alerts on this so that if there's any of those observed locations that are being reported within the named area of interest, we can get a notification here as well. Very similar to what we had in ArcGIS Pro, using the same kind of rule. So if I click on any one of these, we can see which object it is in the map that's being highlighted here. I could do a similar kind of thing if any of the friendly forces are reporting a distress alert. I can see those listed here, and they'll select on the map as well, and I can then perform some further action on that. But this map is the one that I created in ArcGIS Pro Intelligence, and I shared it out as a web map, so we can see some of the other layers that I had created that were the result of the analysis operations that I performed. So that cover and concealment, and then the count of incidents along our lines of communications. So this is just a really simple example of using ArcGIS dashboards to view and work with the same map that we had created and shared in ArcGIS Pro Intel, and then the ability to create geofences and perform analysis in real time on those live feeds that have come in. I also just have a really simple example here of how to display the same information in a JavaScript application. This is just a very simple application that's bringing in the friendly feed and displaying it on the map. It's using the MIL standard 2525 Charlie standard. In the JavaScript API itself, it's very straightforward. You just connect to your layer, you apply the dictionary renderer on it, you tell it how you want to define the symbol. In this case, with this data, there is a symbol ID code that's associated with the feed, and I'm just using that in order to determine the right symbols to display. And we do also enable some additional configuration properties that you can change on the data, such as the ability to turn the icon on and off, turn the text on and off, etc. So there are some additional options that you have here. And this applies for anywhere the dictionary renderer works, whether you're working in the JavaScript API or in the runtime SDKs or in ArcGIS Pro. So those were two very simple examples. There's so much more that you could do with the JavaScript API. So I highly encourage you to explore the API yourselves to get a better understanding of its capabilities. Next, I'm going to talk about a project from a few years ago. We released an open source app for developers who are building situational awareness solutions for disconnected, intermittent, and low bandwidth environments. It's called Dynamic Situational Awareness, or DSA for short. It's written using the ArcGIS Runtime SDK for Qt and includes best practices for key workflows, such as working offline, working with near real-time data feeds, exploratory visual analysis, alerts and geofencing, and collaboration. It's written in 3D, and because Qt supports several platforms, DSA includes an app for more of an embedded desktop in-vehicle environment, and it also includes one for handheld environment, which is an Android application. So next I'll show a video of DSA. It's a great example of a rich custom native application that you can build using the ArcGIS Runtime API. I'm going to use the Dynamic Situational Awareness example app to show how ArcGIS Runtime supports several different local data formats. Using the Add Data tool, I can browse several different datasets on my device. Runtime supports vector datasets such as shapefile. I'll add in here an area of interest shapefile. It also supports the OGC GeoPackage standard. I have here a GeoPackage that I created of some utility infrastructure data in the region. If I query the data, I can see that it's using the DFDD data model. Another way to package data is to use a mobile geodatabase. Here I have a mobile geodatabase of some military bases in the area. When I add it, you'll see that there's not only the data being displayed, but it's symbolized as well. This is one of the advantages of a mobile geodatabase. Runtime also supports raster datasets. I have some QuickBird images here. Go ahead and add one of them. And if I zoom in a little bit, we see that this app is actually in 3D. I have a DTED dataset on my device, and I can add that as an overlay, or in this case, because it contains elevation information, I can add it as an elevation source to the map itself. So as I add it, you see the detail changes in that scene. In this app, we have a few examples of how Runtime can handle high-performance environments. First of all, when I show my current location, We can see how the map updates smoothly as the view pans and follows my current location. We can also see how the app works in a real-time environment. I'll just turn on my feeds. So in this case, the app is displaying a real-time feed of friendly location tracks and a real-time feed of situational awareness events. It's listening on a UDP port for these messages, parsing them, and using a graphics layer in dynamic rendering mode to display them. The dynamic graphics layer was written specifically to support graphics that update frequently, just like in this scenario. Now, if I identify on one of these tracks, we can see what was contained in one of those messages, and it includes a military standard 2525C symbol ID code. In ArcGIS, we use what's called a dictionary renderer to display military symbols. So in this case, I apply a dictionary renderer to the graphics layer, I point it to that symbol ID code, and it displays the military symbol automatically. We have a few examples of using the exploratory analysis tools in the Dynamic Situational Awareness example app. The first one I'll show is creating lines of sight from a set of observers I added to the map from a shapefile. We can see now when I am visible to these observers as my position updates in real time. What is visible along these lines of sight is in green, and what isn't visible is in red. So we can collectively see up here at the top that I'm currently visible by 5 observers. Each one of these lines of sight is actually individual overlays within the app as well. So we can see this in the analysis list. This means that we can manipulate them individually. We can turn them on and off. We can zoom to them or remove them from the list altogether. We can also perform viewshed analysis in the app. There's several ways to do this. I can long press and choose viewshed, and it creates one ad hoc. I can also choose to have one follow my mouse as I move it around the screen. I can change parameters on the fly, so maybe make this one a little bit bigger. And I can also choose to have one follow my current location. So in this case, it's updating automatically as my position updates in real time. I can also choose to change the horizontal angle so that it's less than 360 degrees. And set some other parameters as well. We've made sure that the API supports these 2 types of analysis, location and GeoElement. In one case, with location, you pass it in a coordinate and it calculates that analysis using that coordinate. In the GeoElement case, this is where you can actually attach it to a feature or a graphic that's already in the map display, such as what I'm doing here with my current location. This is really powerful because that analysis updates in real time as that graphic changes. You don't have to make any additional calculations. The ability to be alerted in certain situations is critical in real-time environments. In this app, we wanted to show a way to define rules which would be carried out against the real-time feeds, which would then trigger alerts in the app. We call these rules conditions, and they're constantly being evaluated against the real-time feeds as the data pours in. The app comes with a pre-built condition to alert us when a teammate is in distress. The rule being applied here, though, is against an attribute in the feed when it has a status of 911, but it's not performing any geometric calculations. I have the ability to create a new condition here in the conditions list. I'll create one now that does geofencing, so it'll use spatial analysis to alert me when a real-time feed event occurs within one of the polygons in my area of interest shapefile. So I'll give it a priority. In this case, I'll keep it at a high priority. Select a type. So we want to do spatial analysis in this case. I'll give it a name. And then select the source feed. So in this case, we want it to work against our situational awareness events. And then we can say whether we want to do the geofencing, so within an area of, or the proximity analysis, so within a distance of. In this case, we want to do the geofencing. And then we select our target. So here we're going to say any of the objects or the polygons that were within the area of interest shapefile. And now we're ready to create the condition. And we see that our condition is here. When we look at our alerts, we see we have several alerts in this case. And now, as that real-time feed is coming in, that condition is being evaluated and we're being alerted, and then we can act on those accordingly. Okay, so now we can move into the last section of this presentation. And I wanted to show this slide again to talk about the growing trend with system integrators and organizations around the world who are recognizing the importance of adopting a strategy for using a common geospatial infrastructure and a web GIS architecture to transform how they work. So these are just a few key examples. National Geospatial Intelligence Agency's Commercial Joint Mapping Toolkit program comprises a comprehensive set of geospatial software components and is the recommended toolkit for the management, analysis, and visualization of geospatial intelligence for the US DoD C2I community. The toolkit provides a wide range of development technologies and provides help for application developers. ArcGIS has been the foundation of the CGMTK offering since its inception 20 years ago. So it's not a new concept. And in fact, there was a JMTK program before CGMTK. But it has changed from a vision of providing system integrators with a purely set of APIs and components to work with, to really providing them with a platform that they can build upon. And being able to leverage this platform really helps drive transformation. It helps enable enterprise level collaboration across domains and echelons across US forces. So that's CGMTK. The next example relates to the US DoD response to COVID. Northern Command led this response and were charged with monitoring the pandemic and coordinating the effective deployment of military resources in response to the rapidly evolving situation. Key to this was the need to provide situational awareness and reporting tools across all agencies and organizations involved. However, this was often hampered by a slow development and deployment lifecycle. ESRI were able to connect 10,000 users via an on-premises portal, and as you can see from the screenshots, ESRI dashboards were prominent in the commander's ops center and integral to the tempo and rhythm of the planning cycle. Embedded staff ensured that new resources were identified and resolved quickly, often through simple configuration in a matter of hours rather than the 2 to 3 week lead time that was experienced at the outset. So this was really a game changer for Northcom. And finally, I'll talk about the CommandX system developed by Eurocommand in Germany. The challenge was for organizations tasked with maintaining public safety, the ability to get the information needed to organize it, evaluate it, and transfer that pertinent information to all involved parties. The solution is that they built CommandX as a modern and intuitive electronic command system based on ArcGIS Enterprise and the ArcGIS Runtime SDK for .NET. So it analyzes spatial data in real time. It brings them into a meaningful and informative format. And this results in interactive situation maps for various devices, ranging from a 4K video wall at the command center to the emergency helper's individual smartphones. So within a few seconds, all emergency personnel can receive clear and personalized information concerning operation sections for staging areas. For Eurocommand, being able to partner with ESRI and leverage ArcGIS made CommandX an exceptional product, as you can see the CEO is quoted there on the slide as saying. So those were really quick examples, and we do see this as a trend occurring around the world in terms of organizations and system integrators really seeing the benefit of WebGIS and leveraging this platform to build on for the solutions that they build for their customers. So I'll wrap it up here. In summary, we use ArcGIS to build systems that leverage the technology of GIS and WebGIS as a modern architecture to power a geospatial infrastructure. And then we allow people to work together and integrate information in order to gain a real understanding of the operational environment so that they can make more effective and timely decisions. So finally, before we go into the questions section, I did want to point out that our annual Developer Summit is right around the corner. It'll be held in Palm Springs, March 8th to 11th. And I know we didn't go into any specifics during this session on coding patterns or specific APIs or code examples. But if you're interested in learning more about ArcGIS and how you can leverage it as a developer, I highly recommend that you register for this event. As it says here, it's for developers, it's by developers. ESRI's development staff are the ones who are at the conference giving the sessions and being able to, to talk with you directly in terms of what you're interested in finding out more about. So definitely go to the registration link. It's go.esri.com/DevSummitRegistration 2022. Okay, and so now we're ready for Q&A. Do we have some questions, Scott?
Yes, we do. Thank you, Carrie. Our first question is, when will Symbology definitions work in out-of-the-box dashboards, experience builders, and the built-in portal map viewer? Carrie?
Yeah, they do already today. You can build maps and applications that use military symbology in web applications and in our out-of-the-box apps. The key thing to know about is which app you're displaying it in or which version of the JavaScript API. So the legacy applications, the older version of ArcGIS dashboards, the Map Viewer Classic, Web App Builder, they're all based on JavaScript, the JavaScript API 3.x. And so you just need to make sure that you publish your data using both a feature service and a map service. And that's what allows the military symbols to work in the application. However, our newer applications, the newest generation, so Experience Builder, the latest Map Viewer, the latest version of dashboards, are built with the JavaScript API 4.x. And that's the version of the JavaScript API that includes the dictionary renderer. So in that case, you can publish feature services and you can apply the dictionary renderer on them in order for the military symbols to work in the web application. So today you can build a web map in ArcGIS Pro and you can share it as a feature service, and that'll work in any of these latest generation web applications. In terms of the map viewer for authoring maps, that's something we're working on this year. So you should be able to have the ability to author maps using the map viewer and define your dictionary renderer configuration on your feature layer.
Thank you, Carrie. That was an awesome answer. Very thorough. Next is, when do we expect to release the Maps SDK for production use?
Great, I'll take that, Scott. So right now, the ArcGIS Maps SDK is available through a beta program through our early adopter site. Unfortunately, there's a link on this slide, but it looks like it's gone now. Let me type that into the chat window here. There's a link that'll allow you to join the beta program. It's a public beta program. We have many customers and different use cases being expressed there. It's a very active beta program, open to the public. We plan to transition out of our pre-release into our first production release very soon. We intend to launch the ArcGIS Maps SDK for production use at the Developer Summit next month. We'll probably see the ArcGIS Maps SDK for Unity and Unreal Engine available and released the month after that, so come April. So very soon, you'll be able to use the ArcGIS Maps SDK for production applications. So we're excited to see that going forward.
Excellent, thank you. Great reason to go to the Dev Summit. Is it possible to customize the military symbology that comes with ArcGIS?
Yeah, and as you know, Scott, I could talk about military symbology all day. So yeah, yes, you can customize the symbols. So either the way that we've engineered the dictionary styles is what we call them. You can take the ones that we release as part of our core software, so the ones that conform to the US and NATO standards, and you can add new symbol primitives. You can change things up. You can change the colors or the properties. There's lots of different ways. It's actually incredibly flexible how you can customize those existing styles. And then they'll still work in the same way across the platform. You can also create them from scratch. So this is where we see people some who have more complicated military symbology standards that are similar to the military ones, who want to be able to create their own, maybe for their own industry or for their own, national symbol standard. But people are also starting to create these for their own purposes, just to be able to have more complex and advanced symbology that's really driven by the attribute data. So we really see the interest in the ability to customize dictionary styles really picking up now.
Excellent. Thank you, Carrie. The Australian city video with the building fire, what game engine was that? And with the ArcGIS SDK, Unity or Unreal Engine?
That was Unreal Engine. Yep. That entire
Thank you.
demo was built with Unreal Engine. Yep.
Excellent. Can this do inside building fly-throughs?
This meaning the Maps SDK?
I believe so.
Okay, gotcha. So you can inevitably, the idea is that you could build a variety of different experiences as long as you have the geospatial information. So what's very popular now is being able to build out really a digital twin, an immersive and interactive digital twin of not just the world, but maybe just a specific area of interest. As long as you have the information and the data that you can work with, the interactive capabilities that come along with the game engine can allow you to interact with that data in a variety of capacities. If you want to be able to build a fly-through, as long as you have the experience and the data in place, you can manage and manipulate your viewpoint and your camera perspective from a variety of different ways. So the short answer would be yes. The longer answer is, the experience that you have is really only limited by the game engine capabilities and the data that you're working with at this point.
Excellent. Thank you, Rex. Do we have any additional information on the Unreal Engine demo with Presages?
Yes, there is a link in this slide, actually, using game engines in GIS and simulation. That's a blog post that myself and another product manager for Maps SDK, Steve Heidelberg, put together a couple months ago when working with Presages and Epic Games on this demo, on this prototype, really. It talks a bit about working with GIS and game engines, and talks about the integration of simulation engines. In this context, it was a simulation engine provided by Presages, but as I mentioned in the demo, you could integrate a variety of different simulation engines in that same capacity. So it really is a prototype for how to basically bring these technologies together: visualization, simulation, and be able to interact with real-world data within a game engine. In this case, it happens to be Unreal Engine, to provide, or at least provide more insights to be able to make decisions more effectively. So that link also includes a set of other links to maybe foundational information about the ArcGIS Maps SDK as well. There is a link to the beta program. There's a link to our blog post about the latest pre-release, which has a lot of information about the context of the ArcGIS Maps SDK. So that might be a good start to talk about using simulation with game engines, but it does it's kind of a launching point to other topics about just our game engine integration effort itself. So good place to start.
Excellent. Thank you, Rex. How do we know if an XR device will be supported by the Maps SDK?
It's a good question. Generally, you'll need to evaluate whether or not the game engine itself delivers support for an extended reality headset. I'll say like a HoloLens 2 device, or let's say a Oculus Quest 2. So if the operating system that the device is running is supported by the game engine, so for example, Unity or Unreal Engine can support deployment to that device, that's the first step, actually. So you need to make sure that the game engine supports being able to deploy to a device. The second step is, does the Maps SDK deliver support for that platform or the operating system that's running on the device? So for example, a HoloLens 2 device is running UWP ARM64. Assuming that the game engine, Unity and Unreal Engine support it, we need to make sure that the Maps SDK delivers basically the core libraries that allow for integration on that platform. Same thing might go for, let's say, the Oculus Quest 2, which is running an Android operating system, and so ARM v8, sorry. And if we deliver support in the Maps SDK to support that operating system, then we know that the Maps SDK can be used to deliver support for that headset. So 2 points there. Does the game engine support it? Does the Maps SDK then deliver the architecture, basically deliver the native library that supports integration with that architecture? So those are two different questions there. Just a side note there, so the Maps SDK right now doesn't support every operating system. Every system that Unity and Unreal Engine support, we support Android, iOS, Windows, which includes UWP, and Mac OS systems today. We can also look at extending that to other operating systems if there's good business use cases for it. But right now, we in the Maps SDK have a limited set of architectures that we support.
All right, thank you. We have built some applications with ArcGIS Engine and are thinking about using ArcGIS Engine for a new project. What are the key differences between runtime and Engine?
Right, so I think maybe I'll start there by saying you're working with Engine, you're working with a very extensive, very capable developer product founded on ArcObjects, which is very deep and rich in its capabilities. It's only supported on Windows and Linux, so it's a native application. And so I think the first question there might be, if you're looking to sort of re-envision an ArcGIS Engine application, you might consider looking at whether or not that experience or that workflow can be met, or that solution can be delivered through maybe web technology first, right? So it might be something that you could deliver through JavaScript if it's an application that's connected and the data that you're working with is available through services. If you still want to work with a native application, or you still need to deliver a native application, just a side note here, ArcGIS Engine is set to be retired in 2026. There's no new major releases of ArcGIS Engine, so we know that its days are numbered. So if you're looking to transition to a new native technology, ArcGIS Runtime is what we're certainly encouraging folks to move to. Now, I mentioned before that ArcGIS Engine is built on top of ArcObjects and COM-based structures, so it's very rich as far as its capabilities. It's also very large and extensive. It's only supported on Windows and Linux. ArcGIS Runtime is designed from the get-go, from the very start, to be very refined, high performance, really natively built using C++ logic that targets more platforms, so not just Windows and Linux, but also Android, iOS, and Mac OS. So if you're looking at being able to extend your application to maybe mobile experiences, that would be a benefit to using Runtime. The other part there is that if you do need to continue to support or work with or deliver applications, native applications on Windows and Linux, Runtime supports a variety of different capabilities, access to different data sources, analytical tools, and so it's best to transition to using the native API to be able to access those capabilities. You're going to see better performance in general when working with Runtime. It's lighter weight, it's optimized to run close to the metal with on the operating system that it's designed to support. But at the same time, because of the extensive capabilities of Engine, there might be some situations where there's tooling or there's data sources, maybe older data sources that you need to be able to support. And so ArcGIS Runtime includes something called ArcGIS Runtime Local Server. Local Server is like a mini ArcGIS server that provides access to local data formats or geoprocessing tools that meet some of those needs that you had in Engine, but made it available in ArcGIS Runtime. I think the key thing to keep in mind there is that you're not necessarily going to be working with an API in Runtime that calls, let's say, or accesses a data source directly, like it would in Engine, or a geoprocessing tool like it would in Engine. You'd end up working with really this this sort of mini ArcGIS server. So you're working with a server client experience, even though it's all designed to function on a single machine. Think of it as offline in the sense that you can work with local data, but you really have this out of proc server, ArcGIS server, that's designed to enhance the use of Runtime to meet some of those gaps where Engine supports additional data formats or GP tools that Runtime doesn't natively support today. So I think the key thing to keep in mind there is Runtime's lighter weight, that Runtime is higher performance, Runtime is more extensive as far as platform support, but that you might actually need an additional component, local server, with Runtime to really fill some of the gaps that you had with Engine. But we certainly encourage folks to move towards Runtime. We'll continue to enhance Runtime going forward, and so it's obviously it's a modern development system for native application developers, and we'll continue to promote that going forward.
Excellent, thank you, Rex. From a developer perspective, can these products like virtualization or dashboards be extended with ArcGIS Pro add-ins or with web APIs like JavaScript?
I'm trying to. So the products like yeah, I mean I'm not sure if I understand the question entirely in terms of specifically which products you're referring to. But yes, I mean so ArcGIS Pro can be extended using the Pro SDK. And then we do have some web applications that can be extended either by configuration or also with custom code as well. So Experience Builder is an example of one of those. You can use a JavaScript API and essentially build your own widgets that you can include into a custom application. So there are lots of different ways that you can extend and build ArcGIS for your own apps. But if you have more specifics in terms of what you mean for the virtualization, yeah, it would be good to know, and we can answer that more clearly.
Okay, excellent. Well, that brings us to the end of our live Q&A. We'll send out an email with any additional questions we weren't able to get to, although it looks like we got to almost all of them. Thank you for your time, and I hope you have a wonderful rest of your day.